Here we are, part 2 of a momentum problem. I'm going to base this problem based on the same problem here. However, I would like to say instead of the two objects of mass 1 and mass 2 bouncing off each other and not being separated, I want to think of this as a car crash where the objects become fused or they're stuck together after the collision. So the initial will look and appear to be the same with the same values of M1 and M2. However, with opposite directions. But our final situation here, we're going to get both objects stuck together, and I would like to know which way is it traveling and at what velocity. So we have the same initial variables here. So again, I'll start with the same equation as before, our conservation of momentum. And I'll continue that with the same line that I will have here. So you'll notice this type of question will involve just slightly different level of mathematics. Not that much more difficult, but you do need to think a little bit differently in order to solve it properly. So we still have our initial momentums of both objects. So just if you can see here, we have initial of 1 at 5. I'm going to be a bit lazy here and not use our units. Initial of 2 at 2.5 in the opposite direction. And we have our masses, which do not change throughout the collision. At least we can assume they don't in this simplified version. Okay, so let's ignore that top section. So what are we trying to find? We're trying to find a final velocity. So instead of this v1 and v2, we're just now going to rename them as v. So v and v, because they're going to be a single object. So our next line, we're going to factorize the final velocity outside the brackets. And the reason for doing that is it makes our mathematics a bit more simpler, and it turns two unknown variables into the one. And it just makes sense. We're trying to find final velocity, which is lowercase v, so that's how we're going to write it. So we still have our left-hand side looking the same, like so. So we're still looking for this final velocity here. So I'm going to divide both sides by this m1 plus m2. I'm just going to rewrite that nice and neat, so it's ready for me to substitute. And it's just v, so ignore that. Okay, so I'm going to switch that around onto the left-hand side. So now starting to substitute our values. So that's m1 plus u1, in addition to the second mass plus the second velocity, multiplied by the second velocity. Keeping in mind again, it is in the opposite direction, so we must represent that as a negative. If we don't represent it as a negative, then we will get some complications with the equation. So this is what we're left with, and by solving that, you'll be able to find a velocity. It will be in meters per second. So our final velocity does end up being approximately 1.912 meters per second. We now know our magnitude, so we know our final velocity of 1.912. And we can assume that direction, it is a positive, so that direction, the two objects, M1 and M2, are now traveling in the right hand direction.